Hello everyone, welcome to mentorbuddy.com. This is your mentor Gurvansh, and now I am going to show you the simple linear regression being performed by using Python. Now again here guys, we are going to use the NumPy library, the pandas library, the scikit-learn library, and most importantly one new library, the matplotlib library, to plot/visualize our outputs. Now as you know by now, our first step is to import the library. So here we are going to import the basic libraries which we need. So we have importing the libraries. So let me first cut it. Okay, so the libraries we have over here is import numpy as np, import pandas as pd, import matplotlib dot pyplot as plt. So these are the generic libraries, the basic libraries. After these libraries are imported, we import the dataset. The dataset over here, how we do it? First we write the variable name df is equal to pd dot read underscore csv. Then we write the name of the file. So the name of the file, or the file which I am using here, is the simple regression.csv. All the datasets are available in the mentorbuddy.com itself with the topic headings. Now here also we have the CSV file. The number of rows we have over here is, total number of rows is 31, starting from 1 to 31. The dataset is in 30 rows. We have years of experience and salary, right? Now here guys, what we do is that we write the name of the file, which is simple regression dot csv. Again I am using the tab sign to autofill my particular name. So here I will print my data frame. Now when I print it guys, I will get this particular dataset neatly arranged into columns with years of experience and salary. Now the problem statement over here is that you have to develop a system which is able to know what salary you will get depending upon your years of experience. So here we have years of experience as X and salary as the Y. Now as you know, this is a simple linear regression problem statement. We have only one input variable, only one output variable. Both of them are numeric data type. So we know that we do not need to perform any encoding. Now when we go through it, we can clearly see that there is no missing value, so we do not need to take care of the missing values. Now since we only have one input, there is no reason for any kind of feature scaling. So we are going to skip these three steps. As I have told you that these three techniques are not compulsory. They depend on the data set which we are using. Now since this is a data set of simple linear regression, we do not do anything extra. We are just going to extract our X and Y first. Then we are going to divide our X and Y into training set and the test set to perform our job. So here I am going to show you what we do. So we write from sklearn first of all I am going to divide or extract the X and Y from the dataset, then dataset, and divide them into training set and test set. So here the library which we use is from sklearn.model selection, import train test split. Now first of all we need to extract our X and Y from the dataset. So we write X is equal to df dot ilog all the rows, comma, all the columns till the last column, dot values. Then we have over here y is equal to df dot ilock all the rows comma -1 the last column dot values. Now what I did over here, I just imported the train test split library over here so that I just do not have to do it in different cells. There is no problem, you can import all the library names here in the starting itself. Why I am doing it separately? So that you can directly realize which library is working for what, or which library or which module we are using for which job. That is why I am writing it separately. When we code for our own job, we can write all the libraries, all the modules in the starting itself, because we know what we are using, right? So it is totally up to you. You can either import the library where you are import the module or class where you are using it, or you can import all the class in the starting itself when you know what you are using. So here we write x, then here I am going to print y. When we run it, we will get our x and y extracted. Once our x and y are extracted, we are just going to split into xtrain and xtest. Here I am using small variables to show xtrain comma xtest comma ytrain comma ytest to split it into training set and test set. So we have over here train test split. We got x comma y comma test size. So we have over here 30 rows. Now out of 30 rows we can select any ratio. Let's go with the 75-25 ratio. Then we will set the random state value. I've already explained why we do this. Random state is equal to 0 here also. With this, my x and y will be splitted. Once my x and y are splitted, it means that our data pre-processing steps are done. Since our data pre-processing steps are done, we need to import our actual algorithm, which is the simple linear regression algorithm. So here we need from sklearn. So let me first write the heading for it. We are importing the linear regression algorithm and training it. So we write from sklearn dot linear model import linear regression class. So this is already a linear regression class. It already knows what we have to do, right? So we write over here our regressor. We can create any object. So here I am choosing the name to be regressor. Here we write linear regression, right? This is the class. Since it is already linear regression class, it already knows it is fixed that the data which we are feeding it has a linear relationship within the input and the output data. So once our regressor object is created without any parameters, we do not need any parameters over here. We fit the model in it. Now last time we were using fit transform because we were actually transforming our original data. This time we are just fitting the data using xtrain and ytrain. So as I've told you, in supervised learning, we feed xtrain and ytrain both to the algorithm so that it can create a relationship between x and y in order to train the model. Once you run this, your model will be trained and you will get that the linear regression class has run and your model has been trained. Once our model is trained, we do a very easy task. We use the x test. First we use the x test to predict the output, to get the predicted output, and then we will compare our x test with the y test to check the errors and the R2 score. So here I'm going to write the heading for this cell will be predicting the output and checking for errors and R2 score or R square score. It is essentially R square score, but we say it as R2 because the library which I am going to use will show it as R2 score. So here we write from sklearn. So we are using a library to make our job easier. sklearn.matrix import mean absolute error, comma, mean square error, comma, R2 score. As for our MSC, we just need to take the square root of our MSC. Now first of all, we need the predicted output. So to get the predicted output, I will create a variable named yPredict, and to get the output we use the object name regressor. The function which we use is predict. Very easy. To predict the output we use the predict function, regressor.predict. Here we use xtest. So with the xtest value we are going to get the y prediction, and then we will compare our y predicted output ypred with the y test, which is the original output of those values, and check what is the error. Right? It is the same thing. Like while a teacher creates your question paper, with the questions they already have the actual answers. Now they will give you the question paper, you will solve the answers. The answers which you have solved are the predicted output, and the answers which the teacher will have will be the original output or y test. Right? So when this is done, whenever ypred is done, you can, if you want, you can print it. If you do not want, you cannot print it. It's totally up to you. Here we are directly going to our errors. So first of all, I'm going to write MAE is equal to mean absolute error. So I have already explained you in the last video how do we calculate an error. We calculate an error between y original minus ypred. So here also we write the same thing. So original value is y test and predicted value is ypred. Right? So we say mean absolute error between y test and ypred. Then again I'm going to calculate the same for MSC. So I'm going to write mean squared error between YTE and ypred. Same thing. The function names are different. The values will remain the same. What is RMSC? RMSC is equal to, we are going to take the square root. So now since we are working with NumPy arrays, we are using the NumPy library to perform the square root. So here I am taking the square root of MSC to get the RMSC value. Then we are getting R2 score. So I'm just writing R2 for it. R2 is equal to R2 score again between y test and ypred. So we are just changing the function's value to get the different outputs. Right? When you run this now, okay, sorry, I forgot to print. Okay, so they are calculated now. We just need to print these values. So I will print MAE, then I will print MSC, then I will print RMSC, then I will print R2 score. Print R2 score. Here you can write the headings also. So we can write this is the mean absolute error, mean absolute error, putting a comma over here. We can write mean absolute error is equal to MAE, mean squared error is equal to MSC, root mean squared error is equal to RMSC. Then we have R square score is equal to R2. Running it, we will get these values. Here the R2 score which you are getting is 97%. It means that our model is able to predict with an accuracy or with an accuracy of almost 97 to 98%, meaning there is a shift of 2% in the values. 2% means if the original value is 100, the predicted value is either 98 or 102. So this is the 2% difference. Once we got all of these values, once we got all of these values means once we have done our task, like importing the libraries, importing the data set, splitting it up, training our model, calculating, predicting the output, and showing all of these errors to just check the errors. Our next part is to visualize the output. So we need to visualize the output. Now what I'm going to do is that since we are using X test and Y test to calculate the predicted output and to check the accuracy, we are going to just use them to plot or visualize the output now. So how do we do it? To do this, guys, we are going to use the matplotlib library which we have imported as PLT. And the graphs which we are going to use, as I showed you in the paint, we have the dot values as red colored values. The dot values were the original values. To get a dot plot, like, is known as the scatter plot in the programming language. So we write PLT. PLT is the library. Matplotlib dot pyplot is whole of the module. Pyplot module has been imported as PLT. So I write PLT dot scatter. So the plot we are using is the scatter plot. So I'm going to write PLT dot scatter. Then we mention the x-axis and the y-axis value. So on the x-axis we have x-test. On the y-axis we have y-test. So these are the original values which I am marking right now with the color equal to red. So color I am using is the red color, and then I will mention the size. S is equal to, let's say, 100. So I'm just giving a size so that my dots look a bit bigger. Okay. Now guys, these are the original values which we are plotting. So PLT.scatter, x-test, y-test. Now we need the regression line. So how do we do it? So we use the plot module, plot functions, to plot the regression line. Now regression line is between the x-test, regression line is between the x-test and the y-pred. So as I've told you, it is the predicted output. X-test, the regression line shows the predicted output. Color this time I am using is blue. Now with this we can put the titles also. So PLT.title, we can write the title is years experience versus salary, and the output we are looking for is the test data. So test data, this is the heading. Then we can write X and Y label. So we write PLT dot X label, X-axis label is years of experience, and PLT dot Y label is salary. Then we write PLT dot show to show our plot. Now if you look over here, this is the plot which we are getting. Now the red dots are looking very big. So let's just remove the size parameter and see what is the difference. Now I think it is looking better. Now if you look over here, guys, the regression line is going through at least 4 points, and almost 4 points are not being included. But if you see over here, this is the best regression line our model can produce with an accuracy of 97%. Now the values we have over here, this is the error which we are getting. The errors which we are getting over here, these are the accumulated errors of the values of these shifts. Okay, so this is how we perform or how we solve a simple linear regression problem statement in machine learning using Python programming language as the base. Thank you guys for joining us on Mentor Buddy. I hope now you understand the logic behind simple linear regression and how to actually perform it using Python.